All right, so here's the video for this assessment. I'm just gonna go over everything like I've done in the past here. Um, all right, so evaluate integral of x dx. Uh, it's actually a simple problem, although it looks kind of difficult. We just find the antiderivative of x, which is 1/2 x squared, and don't forget to add plus c. That's it. Yeah. Same thing here. Very simple problem actually. We just find the antiderivative, but then it's FTC, so we'll need to plug in some values. Antiderivative of 1 is just x plus, this one be 1/4 x to the fourth from 1 to 2. So plug in a 2. So we get a 2 plus 1/4, 2 to the fourth, 2 times 2, 4 times 2 is 8 times 2, 16. That's just 4, so 2 plus 4, so that's 6. And then plug a 1 in, and I get 1 plus a fourth. So let's see, 1 plus a fourth, that's 5/4. So it's just 6 minus 5/4. Let's see, 6 minus 4/4 would be 5, so it's 4. Well, I don't like to write it that way. Let's just do it this way. It's 24 fourths. Let's do that, 19 fourths. Cool. And of course, that's one that we can easily just check in the calculator as well. So I'm going to do that. There's no FTC, we can always check in the calculator. So let's see, integral from 1 to 2 of 1 plus x cubed dx. That's the same as 19th. Excellent. Yep. All right, moving on. Area. Okay, so these should seem a lot easier compared to all the volume problems we've been doing. 0.2x to the third and x. In the first quadrant only, though. So it kind of looks like here's this one that's 0.2x cubed, and then here's this one that's just y equals x. Just that area right there. So we just do top minus bottom. Let's see. So and it's dx. So let's see. This is from 0 to 2.236. Top is 0.2x cubed minus the bottom of just x, and that's dx. All right, so I just threw it in the calculator. Glad I checked it. I messed up. This is the top function right here. So let me just switch that real quick. 0 to 2.236. It's be x minus 0.2x cubed. X. All right, because this one got me a negative number. So I'm glad I went back and checked that. All right, in this problem we got this little setup right here, taking this area, rotating around the x-axis. That's all looking. There we go. That's better. All right, so I'm looking at it, and I'm looking at it. I'm going to say, oh, sorry, not the y-axis, the x-axis. This one here. Yeah. So I'm looking at it. I'm going to say that's a washer method. You got an outer and inner right here. So let's just set that up from 1 to 3. The outer, that's the top one here. See, that's going to be 2 over x. So it's pi r squared. That's the outer. And the inner is just going to be 2 over x. No, sorry. 2 over x is the outer. The inner is going to be the green one. So minus pi r squared. And the inner one is 1 over x dx. And that's right there. I'll look at the decimal approximation. All right, now we're continuing on. Same region. So I've got just kind of sketched it back here. This is the region here. We're already trying on the y-axis. This one's a little bit tricky because if you look at the picture, we can't just use a simple washer on this one because, well, I mean, we could. We'd have to chunk it up into 3 different regions, and then you could do washer if you did 3 separate ones and add them together. Instead, I'm just going to do shell. I'm just going to shell with the vertical slices. So here's kind of my, a crude drawing of a shell for that. Actually, let's like that. Oh, yeah, I want to erase it. There we go. What about? There we go. So kind of a shell slice right there. Okay, so notice my drawing there. That's a vertical slice. So let's see, from 1 to 3, shell that's 2 pi r times the height. Let's see, the r, since we're just going to the y-axis, that r value is just this distance right here, which to each slice is just the same as the x value. So that's convenient. And then the height, that's going to be the top one minus the bottom one. The top one, let's see if I can do it right this time. The top one is 2 over x minus, and the bottom is 1 over x. 1 over x. So 2 pi r times the height dx from 1 to 3. All right. Let's see. Do I need to? Yeah. Okay. All right. So for each of the following shapes, the base of the volume of the region is bounded by these. Just let me sketch these here. 8 minus x squared and x squared. You get something kind of like this. So I'll just be using the same region for each of these questions. Cross sections perpendicular to the x-axis. Good, so I'm using vertical slices like this. All right, square. So let's see. Square, they intersect at -2 to 2. So we got that going. The area of a square is base times height, or just the, basically this length squared. That's the area for it. Well, that length is the top minus the bottom. So 8 minus x squared. Good. So the blue one's the top one. Night. Minus x squared. So that's the top minus the bottom. And then we just square that. dx. What is it? Yeah. So let me just. Okay. All right. Draw triangle. Okay, next one. So same base, same shape and everything. But now, so -2 to 2 still, but it's just going to be an equilateral triangle. So I'm still using that same exact thing from before. That right there is the length of one. That's just one slice right there. That's the base of it. But this time it's square root of 3 over 4 times the squared dx. Okay. All right, moving on. Same shape as before, but now it's going to be semicircles. So let's see. The area is pi r squared all over 2. So from -2 to 2, 8 minus x squared minus x squared. And if it's annoying to you that I've been doing this and you want to put minus 2x squared, obviously that's fine. I just like showing because it's this one minus this one. So I got pi r squared over 2. So I'll just put the over 2 out here. Now, careful though. This value right here, it gives me the whole length of this base right here. But when you're doing a circle, it just wants the radius. So basically, how could we only get half of it? Well, we take this and we divide it by 2. So that's it. Yeah, and make sure that this 2 is in part of the r where it's getting squared. So you wouldn't bring it out and make it 1/4 out front. Dx. Okay, let's keep going. All right. I'm showing the region. Oh, the circle. Yep. Okay. Let's see. The center's at 2, 4. 4. And okay, yeah, 2. Okay, and it's radius of 3. Kind of like that. Right on the x-axis. Okay, so I'm gonna do washer. I'm gonna do washer on this one. And let me get my graph ready here. This is x minus 2 squared plus y minus 4 squared equals 9. Great. Yeah, I'm gonna do washer. So that means I need an inner and an outer. So I'm basically cutting it up like this so that I have an inner one and an outer one. And to do that, I need to solve for y. Now that makes sense. I'm using, this is a washer. Washer. And with vertical slices. So when I solve this for y, that means I'll get y equals a bunch of stuff with x's in it. And that's okay because I need x's in my integral. So let's see what happens. Move that over there. I get y minus 4 squared equals 9 minus x minus 2 squared square root. and then gets rid of that. Oops. I didn't mean to do that. Oh. Okay, square root all that. That gets rid of the square root. And then I'm going to add 4 outside there. So I get y equals the square root of 9 minus x minus 2 squared plus 4 on the outside. Now that just gives me this blue one right here, though. I'm just going to graph that and double check, though, make sure that's what I want. I would always graph these and double check them as you go. So it's 9 minus x minus 2 squared. And then the outside plus 4. Yep, it gives me the top one right there. And then that means the bottom one, the green one, would be y equals negative 9 minus x minus 2 squared plus 4. And let's double check that. Copy, paste it, put a negative in front. Yep, good deal. So the blue ones are outer. So let's just do this here. So from, I'm looking at my graph here. This looks like it goes from -1 up to 5. Pi r, but r is going to be all of this one. 9 minus x minus 2 squared plus 4. Pi r squared minus pi. And then the negative one, that's the inner. X minus 2 squared plus 4 squared dx. The vertical slices, -1 to 5. Good deal. Okay. Ooh, create and solve a shell method. Oh, oof. So obviously I've already done that a few times here. I'll just give you a quick example. I'm not going to work it all the way out, but say you've got, and this is the easiest one that I always go to. Say you're going to rotate y equals sine of x from, let's do something simple here. Sine of x from 0 to pi. 0 pi. So that kind of looks like this. Okay. Now there's a pi 0. This one's and then we want to rotate it around this. So sine of x for this integral, or you could say like bound by y equals sine of x and x equals 0 and x equals pi. That would be the same thing. You know, just kind of limit you to this little area right here, and rotate around. Around the y-axis, because then you'd be forced to use shell instead of washer. Around y-axis. Oh, let's just go and finish that one. So it'd be 0 to pi, 2 pi x times sine of x dx. That would get us that. All right, so now for this language question here. We've got which integral below gives volume of the solid revolution obtained by. Okay, so it'll kind of look something like this. Let's see, you got an axis, you got like this line, you got this line, and they're rotating around this line over here, which is at x equals 3. Or 3, okay. Okay, so looking at all these possible answers, there's a 2 pi. So that kind of tells us that it's going to be a shell. They're using shell here. So that's 2 pi r times the h. And they're using, this is they're all dx, all vertical slices, all rotating around this line right here. So let's break it down a little bit. Let's see. So the correct answer then would be like, so you want look at the for the r value. Here is the line. And you're asking, well, how far is that from here to any point in this slice? Well, if this whole distance is 3, and then you're taking away this bit right here, which is the x value. See, every slice, here's your x value, and then this distance right here would be 3 minus the x value. So 3 minus x, that's your radius here. Except, yeah, that's fine. 3 minus x. And then the height, so we got 2 pi Sorry about that. Huh. 2 pi, 3 minus x, and then we've got the height, which would just be top minus bottom. So that's kind of nice. Let's see, the top one here is square root of x. So h would be the square root of x minus the bottom function, which is x squared. Okay, so square root of x minus x, oops, minus x squared. Let's see. No, sorry, just there we go. Okay. Excuse me. And then dx. So they all have the same bounds. Okay. Well, let's just pick out some easy ones here. Some obvious ones like can't be a because there's no pi right there. All right. Let's see. You could say this one can't be it because this is e can't be it because they do 3 minus the square root of x, which would limit you to just 3 minus this distance, and it wouldn't help you get the radius of each one. So it's not that. You could say, but this one right here, like this one, they have the r as being the square root of x plus x squared. I'm not really sure where that part came from. So there's a couple of these ones. I guess that right there is already answered. Same thing here, 3 minus pi over 2. I'm not really sure. Sorry, x minus 3 over pi, 3 over 2 pi. I'm not really sure where that's coming from. Yeah, so there you go. Some examples you could have for that one. What the? Okay. All right. I'm just gonna erase the other way. Consider the shape rotating. That's really annoying. Consider the shape created by rotating the region bound by that y-axis. Okay. So let's throw this in the graph. We got 2 for 1, and x equals 1, and y equals 1. Okay, around the y-axis. So it kind of looks like, let's see, I got my axis here. I got this line, I got that line. I'm doing that around the, around the y-axis. Yep, so right here. Okay. Yeah, it's up to you, all these things. You just have to explain it. Like, so for me, I like sticking with vertical slices. That's just usually easier, especially the way this is given to me in this problem here. So I would use, oh my goodness. So actually I'm gonna write it all down. I'm just gonna say it. I like vertical slices. So that means I'd be using shell. And again, that's part of why I like to use it. As I just said, it gives me x cubed plus 1. So I don't really have to do any algebra. Vertical slices with the shell method. And I think that's about it. Yeah, so just explain like why you like that. That's for me. The vertical slice is much easier for me. I mess up whenever it comes to horizontal. So, and then that's shell method, which is also not that bad. 2 pi r times the height. So, all right, that's it.